Reduce row echelon form properties. The following four properties are what defines if a matrix is in the form of a reduced row echelon. If a row does not consist entirely of zeros, then the first non-zero number in the row is a 1. We can see this when we look into this matrix. Our first number is a 1 in this row. Our first number is a 1, and also our first number in this one is a 1. There's a 0, there's a 1. If there's if a row, remember we're talking about a row. If a row does not consist of entirely of zeros, this row does not consist of entirely of zeros. So the first number, non-zero number, is a 1. The same as here, the first non-zero number is a 1. Here we got zeros everywhere, so it doesn't really matter because we don't have any other non-zero number. Then second property says if there are any two rows that consist of entirely of zeros, then they are grouped together at the bottom, like here, if the row is being put at the bottom. Then if any two successive rows that do not consist entirely of zeros, the leading one in the lower row occurs at the further to the right and the leading one in the higher row. So our leading one in this first row is this one. Then the next leading one in a row that does not contain entirely of zeros is this one. As you can see, it's further to the right than this one. This one is further to the right, this one is further to the right, and this one is further to the right of this one. Then this is the tricky one. This is usually the most tricky one. Number 4, each column that contains a leading one is 0 everywhere else in the column. So we have a leading one. Our leading one is here. So this and this should be zeros. This and this should be zeros. Please contrast this with this one. This column does not contain a leading one, so it does not matter if it has 2 here, because it does not have a leading one. This column, remember we're talking about a column, not a row. We're talking about a column, not a row. So the leading one is 0. The column is leading one. This is the leading one. There are zeros here. This is the leading one. There are zeros here. This is leading one. There are zeros here. Leading one. There are zeros here. Zeros here. Zeros here. Zeros here. Because those are leading ones. So these two here does not make this matrix not to be in a reduced row echelon, because it does not occur on top of a leading one. We can contrast this with an example where the matrices are not in reduced row echelon form. For instance, this matrix is not in reduced row echelon form because of the row number 4. It does not contain zeros everywhere else in the column where it has got a leading one. This is leading one and it is a 4 here, so it does not become a reduced row echelon form. This one has got a leading one here, and these other items, they are not zeros, so it does not become a reduced row echelon form. And this one, we got 1 here, but there is another number here. They are supposed to be zeros on top and bottom of, on top or in all other places above or below a leading one. If you look at this one also, this is the leading one. There is 1 here and a 2 here, and this is the leading one. Remember, this is the leading one, and we're saying because now this is the leading one and there's a 2 here, there's supposed to be 0 here for it to be in reduced row echelon form. The same here. Here we don't have. If there was a 0 here and this was a 6, this would have just been in a reduced row echelon form. So the problem that it caused it not to be in a row echelon form is this 2. Okay. We're going to go through an example in your prescribed textbook which explains, where we're going also to explain which items are in reduced row echelon form and which ones are not. It's on exercise 1.2, page 22, question number 1. We are supposed to determine whether a matrix is in a reduced row echelon form or just in an echelon form. The first one is easy. It's S1. The first one is in a reduced row echelon form. So this one is in reduced row echelon form. If I look at the leading one here and I look down and say, okay, if this is my leading one, then I'm supposed to have zeros here. If this is my leading one, on all places in the column I should have zeros. If this is the leading one, I'm supposed to have zeros here. And if this is the leading one, it should okay further to the right than the one on top of the leading one on top of it. And this one, okay, is further to the right than the one on top of it. Then I go to B. I look at B and say, okay, B also, this is my leading one, so zeros here. This is my leading one, so zeros here. This is also 0, 0, 0, 0, so it doesn't really affect. So it is also in reduced row echelon form. Then I look into the next one, C, and say, this is my leading one, and this leading one, okay, say that's the right on this one. Then there are zeros everywhere where the leading one is, so it is in a reduced row echelon form. This is my leading one, and this was my leading one also. So if I look here, in the column itself, there's a 0 here, there's a 0 here, so there are zeros in those columns of the leading ones. Then I look at this one. This is not my leading one. This is not a leading one. The leading one is this. So this does not really affect here. And I'm looking at this and say, I don't have another leading one. So this is 3, 2. So it doesn't really affect whether this is now a reduced row echelon form. So this matrix is a reduced row echelon form. Based on the fact that it meets all the qualities of a reduced row echelon form, because there is no leading one. If there was a leading one, the leading one was in, if there's 3 here, then there will be, we'll say it's not a reduced row echelon form, but there is no 1 here, so there's a 2 here, there's a 3 here, so it is in a reduced row echelon form. Then you look at the next one. There's 1 here, this is the leading one, and there are zeros here, so it is in a reduced row echelon form. There is a 2 here, but remember there is no leading one here. The leading one is here, so it does not really affect. And the way the leading one is, I've got 1, 2, 3, I've got zeros everywhere in that column. Remember, it says the column, not the row. And it says the first number that occurs in a row should be a 1, and the first number that's occurring here is a 1. Okay, first occurring here is 1, first occurring here is 1, first occurring here is 1. It doesn't state anything more about the numbers following. It states the first one. The only other time it mentions about the leading one, it's in 2 places where it says it should be further to the right, and also of the leading one, there should be zeros. So when you look at this is not a leading one. So don't get confused. This is not a leading one. This is the leading one. Then on the next column, on the next row, this occurs at the further to the right. So this matrix is in a reduced row echelon form. Then the last one, then F, which is not necessarily the last one, F is also in a reduced row echelon form. This will the fact that it consists of entirely of zeros. Then the last one, G, which is on page 22, is not in a reduced row echelon form. It's merely from the fact that this leading one, there is a minus 7 here. They're supposed to be zeros here. They're supposed to be zeros on top or below the leading ones. So this is just in echelon form.